Now we are going to do the miscellaneous exercise of limits. Now that we've done the chapter, let us see what are the various difficult sums or slightly more interesting sums or slightly more challenging sums that you can get. Right? Let's see the miscellaneous exercise. Let's see the first sum. Limit of x tends to 1, root of x square minus 1 plus root of x minus 1 upon root of x cube minus 1. Right? Now, let's see how do we do this sum. This can be written as limit of x tends to 1. X square minus 1 is in the form a square minus b square. A square minus b square can be written as a plus b into a minus b. So, this can be written as x plus 1, x minus 1 plus root of x minus 1. In the denominator, I can use the formula a cube minus b cube. A cube minus b cube is a minus b. Here, this is going to be a minus b, a square plus ab plus b square. Now, limit of x tends to 1. In the numerator, I could take root of x minus 1 as common. That leaves me with root of x plus 1 plus 1. In the denominator, this can be written as root of x minus 1 into, since it's multiplication, root of x square plus x plus 1. I can cancel root of x minus 1 in the numerator denominator. Once I cancel, all I need to do is just substitute the values. Let's substitute the values. This is going to be 1 plus 1 plus 1 upon 1 plus 1 plus 1. So this is root 2 plus 1 upon root 3. That shall be the answer. Let's see another sum. Limit of x tends to pi by 4. Sin x minus cos x the whole square upon root 2 minus sin x minus cos x. Now since x does not tend to 0, you have to make it 0. How do I make it 0? You will say let x be equal to pi by 4 plus h, as x tends to pi by 4, h tends to 0. Right? Now this can be written as L is equal to limit of h tends to 0. This is sin x can be written as pi by 4 plus h minus cos pi by 4 plus h the whole square upon root 2 minus sin pi by 4 plus h minus cos pi by 4 plus h. Right? Now, this is going to be limit of h tends to 0. Here, you will use addition formula. Right? So, if I use addition formula, this is going to be sin a plus b. So, this is sin a cos b plus cos a sin b. Expansion of the first bracket minus cos a plus b is nothing but cos a cos b minus sin a sin b. Expansion of the second bracket using addition formula, the whole square upon this is root 2 minus expansion sin pi by 4 sin a cos b plus cos a sin b minus cos pi by 4 cos h minus sin pi by 4 sin h. Right? Do we get this thing here? Now, pi is 180. 180 divided by 4 is 45. Now, this is going to be limit of h tends to 0. This is sin 45. Sin 45 is 1 by root 2 cos h. That means I could write this as cos h by root 2 plus sin h by root 2 minus cos h by root 2 minus into minus plus sin h by root 2, because cos 45 and sin 45 both are 1 by root 2, the whole square, upon root 2 minus, this is going to be cos h by root 2 plus into minus sin h by root 2 minus cos h by root 2 minus into minus plus sin h by root 2. Right? Now, plus cos h by root 2 minus cos h by root 2 gets cancelled. Similarly, here sin h by root 2 minus sin h by root 2 plus sin h by root 2 gets cancelled. This is limit of h tends to 0. Sin h plus sin h is nothing but 2 sin h by root 2 the whole square upon, this is root 2 cos h by root 2 cos h by root 2 minus 2 cos h by root 2. Right? Now 2 and root 2 will get cancelled, so limit of h tends to 0. Root 2 sin h the whole square, this root 2 and this I cancel to give you root 2 upon, same thing in the denominator, root 2 minus root 2 cos h. Now in the denominator I could take root 2 common, so limit of h tends to 0. Root 2 the whole square is 2. Sin h the whole square is sin square h. Root 2 common, 1 minus cos h. Now since I have 1 minus cos h, I will have to rationalize to convert this into sin. So into 1 plus cos h, 1 plus cos h. I am rationalizing the denominator. Limit of h tends to 0, 2 sin square h, 1 plus cos h upon root 2, 1 minus cos, this I could cancel. I will cancel this later. 1 minus cos h, 1 plus cos h is 1 minus cos square h, which is nothing but sin square h. Right? Sin square h in the numerator, denominator gets cancelled. Root 2 and 2 gets cancelled to give you root 2. So your answer is going to be root 2 1 plus cos of 0 is cos of 1. Cos of 0 is 1. So in that case, this is going to be 2 root 2. Right? Let's see another sum, people. Limit of x tends to 1, ab raised to x minus a raised to x b upon x minus 1. Right? Let's see this. Multiply and divide by AB. Why am I doing this? So that I can get the numerator in the exponential form. See how I do this. This can be written as limit of x tends to 1. I'm going to divide by AB. No, I'm going to multiply by AB and I'm going to divide by AB. So this is ABX upon AB minus a raised to x b upon AB. I have multiplied by AB, I have divided by AB. Denominator x minus 1 as it is. Cancel, 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 cancel. So this is going to be limit of x tends to 1, AB, this is nothing but b raised to x upon b is nothing but b raised to x minus 1. right? Minus a raised to x minus 1, same thing, a raised to x upon a upon x minus 1. This can be written as limit of x tends to 1, ab. This is going to be b raised to x minus 1, subtract 1, add 1 upon x minus 1. Here, this can be written as limit of x tends to 1, ab, b raised to x minus 1 upon x minus a, take minus sign common, minus 1. Split the numerator. So this is upon x minus 1, x minus 1. Right? Use the exponential formula. That means this is going to be log b minus log a. Answer is ab log b upon a. I use the formula a raised to x minus 1 upon x is log a. Right? Do we get this thing clear? Next, let's see. Okay, we have another sum. Limit of x tends to 1 log 2x to the base 2 raised to 1 upon log x to the base 2. Copy this up correctly. Okay. Let's see this. Now, log AB can be written as log A plus log B. That means this can be written as limit of x tends to 1. This is nothing but log 2 to the base 2 plus log x to the base 2. Log AB is log A plus log B. 1 upon log x to the base 2. Log 2 to the base 2 is nothing but 1. This is 1 plus log x to the base 2 upon 1 upon log x to the base 2. Exponential formula. This is nothing but e. 1 plus x raised to 1 upon x. Your answer is e. This finishes your limits.